get this music done and out of the way. Hope you're doing well today. I'm Jared. Here's another rendition of Zephyr 101. Today we are going to talk about starting a project completely from scratch. So it's not that crazy, it's not that complicated. There are some tools out there to make it a little bit easier for you, and we're just going to go over that right now. If you haven't already subscribe to the channel. Leave a thumbs up if you'd like. Subscribe if you'd like to get notifications when I do new videos. They are at various times throughout the week. It really depends on whenever I can get to putting some content together for you guys. So this week is another kind of request that came in through another one of my earlier videos. It's basically Zoe here is just looking for kind of a full project setup, blinking LED, and then using that same project for another circuit board. So we're going to do that today. We're going to configure the minimal pieces to getting a working project. These are the things that I've talked about over and over and over again, but we're just going to be putting the minimal pieces that you can at least get to a compilable example. This is configuration, CMake lists, kconfigs, things like that. We're blinking an LED. It's actually, we're using one of the off-the-shelf samples that's provided inside Zephyr. And I was just kind of copy and pasting the parts that are important. We're going to port it. So one thing that's different in Zephyr versus maybe another RTOS or whatever is that if you have it set up correctly, there's no porting per se. There are some board definitions that kind of define what your hardware is capable of doing. But beyond that, the ideal situation is you can use the same code for one chip as you can use it for another chip across vendors, across modules, across everywhere. So that is the power of Zephyr. And there's added complexity to that. But once you kind of get the complexity, you'll have a better idea of actually how it works. So here is the file structure, the basic file structure, the things that you're going to need, minus maybe the boards folder. So we're going to create a base folder. We're going to call it whatever you want to call it, Zephyr or app or whatever. I like putting things in another folder below it. This is where all your source code lives. I call it app. You can call it whatever the heck you want. But in this case, we're going to keep it app because there is some things we have to keep consistent in the west.yaml, the west manifest. So something to keep in mind. But all these parts should look familiar for everybody who's watched this channel before. And we'll see in a second here. You can also ignore that the Zephyr folder because that's pulled in later on. It's not necessary for setup. So actually, I will pull this back out one second. You can see all these. Where's my finger here? Here. You can do a git init in the app folder and then add all those things to your repository. It doesn't really matter any files outside of, so like Zephyr or repo and things like that, you don't need to check it in. So that's just one brain blast I just had just to keep in mind. So one thing that I like to do is I kind of like showing. I develop a Nordic, so I like to show the NCS variety, and I also like showing the vanilla Zephyr just for contrast. It's also one of the options in the Circuit Dojo VS Code tools. If you have VS Code and you use Nordic parts, you're more than welcome to check that out. I did put a link to it in the description. But this is the copy of the West.yaml that we've put in place here. Essentially, we're just setting the main remote, the main project to be NRF Connect SDK, setting the revision. The import true is also very important. It'll make sure that you've recursively pulled everything, all the requirements. And if you don't, then you will not be able to build your project, most likely. The path setting to app. So that's what I was talking about just a minute ago, where I was referring to we have to keep things consistent. Whatever you name your application folder to, it needs to be set also here in the West manifest. So something to bear in mind. If it's something different, when you try to compile, it will basically say, this is not a project. You can't compile this. Help me. essentially that's what West will say. Similarly, here's a vanilla configuration. This all looks familiar, should look familiar here, but the big difference is changing the URL base, and then also the repo path, I believe, is different. So yeah, their repo path for NCS is SDK NRF. For Zephyr, it's just simply Zephyr. So that is the basis for at least getting started. You can initialize and get all your dependencies. So just with the West YAML, you can start initializing actually using things. So the West init -l, so -l is for local, and then you want to indicate the folder where the West manifest is located. So this will all it'll do is just set up a .west folder in the root, which has all the important information on exactly how to bring everything up, and then do a West update, and that's where we pull all your requirements, all the repositories. It'll download everything recursively, so on and so forth. Power of Zephyr. And then if you haven't already, typically you're not going to have a Zephyr folder before that. So once it arrives, you can do a pip or pip3 install, and you can install all your Python requirements. And typically these are all the kind of scripts that are used for compiling your application, or merging hex files, or signing application binaries, things like that. So without those, typically you won't be able to build your application. So this is also pretty important. And for anybody that's set up the SDK before, you're very intimately familiar with this requirement. So we've gone over those three main steps. This is just setting everything up. This is setting the stage for actually getting to a compilable application. So next thing, we're going to create that project.conf file. This is going to be inside the app folder. And the most important thing here is we're blinking an LED, so we're just going to make sure GPIO is turned on. Typically, for most boards, it already is, but if you want to make sure that it is, you can set that up here. So I believe for the two boards that I actually used before, they're both set up. So, and then I mentioned that boards folder. This is circuit dojo underscore feather, or nrf9160 underscore feather underscore ns.conf. So I like using that board has a bootloader built into it that you can do transfers over USB via the UART to USB adapter, or the IC. So I just want to make sure that for this particular board that MCU boot is enabled. If you're doing kind of bare metal, you're programming using a programmer, NRF-JProg or JLink or whatever, Seeger or whatever else you got going on, you don't really necessarily need this, and it might not help you anyway if you don't have a bootloader on your board beforehand. This is the CMake. This is the very minimal CMake list to basically say, hey, I have a Zephyr project. I want to pull everything in. This is the name of it, Project Blinky, and then we want to make sure that we target the main.c file. So we're going to create a main.c in a source directory, src, and we'll get to that content right now. So inside, we've created if you haven't already, create a src file folder, and then created a main.c file. This is the sample from the Zephyr SDK. So I'm just adopted it because it's very simple and straightforward and easy peasy. So easy peasy. You can see here we've set there are some constants that have been set, and also just like a DT alias. We're just creating a macro for it. I don't know really why they did that, but it kind of splits things out, so it's a little bit easier to read when you're using the DT spec get. So I like the GPIO DT spec because it allows you to pull all the things that have to do with the GPIO in one go, and then you can use the GPIO DT API rather than the GPIO API, which is just a little bit more complicated. This is the closest thing that you can get to where for those who are coming from bare metal, you're used to just toggling bits in a register. This is essentially kind of the same thing. You can kind of toggle on and off with this one DT spec struct, so it's handy. In the main here, we're just checking, make sure that there's no weirdness in the LED. LED is just using the GPIO peripheral. So if there's something wrong with the GPIO peripheral, this is bad and no bueno, and most likely there's something wrong with your chip. I don't think I've ever seen any type of failure that far, but this is kind of the standard in terms of using drivers in Zephyr. Maybe it's more complicated. Maybe you're using an I2C device, SPI, anything that's attached to an actual interface. These are things that you actually want to be checking 100% for sure. And then we are going to configure that LED as an output or output active, so actually turn it on, and that information will be depending on how it's configured in the device tree. And then we are just simply toggling it and then putting a delay. So this is the basic main C. It's just going to blink an LED on and off for forever. Can't talk today. So we're getting the LED 0 device. We're making sure it's okay. We're toggling the output, and then based on whatever you've defined as LED 0 and the DTS file, and this might be something that you've not defined yourself. So this is where a lot of things might be outside. When you're first starting, you're first getting going, you're setting up a new project, you're like, okay, I want to use this board and I want to use the LED, and so happens that the LED 0 alias is set correctly, so you can just kind of use it out of the box. In this case, both of them were set up, so you can see here. So this is this is what I did in the common DTS file. You can see LED 0 is the blue LED, and then further on down into the file, you can see how the LEDs are defined. We're using port 0, pin 3, and it is active low. So when the input of that, or when the output is set to 0 volts, you will get an LED turning on the NF9160 feather. And I think it's now reverse polarity. I think this is one of the older definitions. But this is something you might, when you're starting up a new project, you might not have to change or do anything as long as it's set correctly in the board definitions. So here is as a contrast, this is what the Xenon looks like. So they've actually defined LED 0 as user LED. If you go down into the LEDs, you got user LED, which is using port 1, pin 12, and this one is actually setting GPIO active high. So this information, when you're using the GPIO DT implementation, is all being used, so you don't have to worry about what polarity. Everything's set in the overlay, or not in the overlay, but in the device tree. So that's nice. And if you ever have to make a change or anything like that from a board level, you can either change the DTS from the board level, or you can actually add an overlay. So, but that is the path for both of those files. If you're curious, you can actually go right to them. They're both in the Zephyr repo, just for giggles, if you want to go check them out, or for maybe this is your first time looking at something like this. This is the type of stuff you should be able to look at and see, okay, how's my board set up? What is LED 0? So on and so forth. Usually it's an LED that's actually on the board somewhere that you can just kind of turn on and off. But if you don't have an LED 0, then you'll have to define one yourself. GPIO LEDs does not make sense. Okay, Costas. Let me see. Oh, so the GPIO LED. So compatible is, but this might be another subject for another video, or going back to, this is the way you can kind of define different devices, and it's kind of like a outline or a way to say, hey, this device has these certain entries. So they're kind of like, it's like a specification for an entry in a device tree. But if you guys want me to cover that, I can definitely cover that. I think I've talked about it in the past, but if you want me to talk about it a little bit more, this is more related to creating drivers and things like that. So, but that compatible, that is also used, say, like I have an LAS2DH accelerometer, that compatible is saying, hey, I want to use this particular driver for the LAS2DH. So that's the general idea there. Yep, Yeah, guys, 100%. The binding of files is really the heart of it all. So that's the definition of whatever device you want to use is what it is. So thank you for piping in there, you guy. Building and flashing, if you are using the command line, if you are using the command line, you got the build commands here, particle xenon, whatever board you're building, and then you're also just gonna be flashing depending on the situation. So, and then finally here, so I created this project manually, adding all those files. Literally, using Zephyr tools, create project will do the exact same thing for you, and you can actually choose whether or not you want to use NCS or vanilla Zephyr. So it's really up to you and how you want to do things. I have people come and talk to me like, hey, I want to use this with an STM32. There's no support for that right now, but if you'd love to, I'd love to look at a PR. I'm accepting PRs every day, any day, if you'd like to see that happen on the SD or the plugin. I'd love to see that happen. So it only takes a few files to create a project from scratch. The rest is handled by West, which is great. But you have to basically set all that stuff up. So this is Sans setting anything up or any tool chains up, because I'm assuming you've already done that. It's easily portable between different boards, so it's great because all you're doing is just using an alias. And you can actually check out my ZDS talk, Zephyr Development Summit, on the topic of basically creating an application and then using it across different boards. It's a little lengthy. I know some people are like, oh my gosh, it's so long, but it kind of goes in step by step and how it works. So I also put a link to the Zephyr Tools plugin in the description, so you can go check it out, see if it works for you. I'd love to hear your feedback if it's working for you or if it doesn't. I'd love to hear from that too. So, but it sets up the tool chain for you, all the Python dependencies. You can create a new project or you can load an already existing one. And like I said, PRs are more than welcome. So if you'd like to see more content, please leave a comment down below. And yeah, I got to get running, but thanks for being here, and I'll see you on the next rendition of Zephyr 101.